All right, everyone, let's go ahead and talk about average atomic mass. And if you remember, the average atomic mass is represented on the periodic table. So whenever you see the atomic mass on the periodic table, that is an average mass. And so the atomic mass, or the average atomic mass on the periodic table, it is the average mass of all existing isotopes for that element. And so this will depend on the abundance of each isotope. And so you'll see that there's certain isotopes that have a higher percent abundance. For example, carbon has a higher abundance of carbon-12 than carbon-14. And so there are many types of averages, such as mean, medium, and mode. Average atomic mass is a different type called a weighted average. Now, let's go ahead and talk about what a weighted average is. If your grades were 90, 90, 90, and 80, what would your average grade be closer to? Would your average grade be closer to a 90 or an 80? And so it would be closer to a 90 because you have a higher abundance of 90s. And so because you have 3 90s and 1 80, it'll be closer to 90. Another example, if your electric bill is $100 per month during the colder months, which is 33% of the year, and then $200 per month for the rest of the year, which is about 2/3 of the year, would your average be closer to 100 or would it be closer to 200? Well, the answer would be that it would be closer to 200 because there's a larger percentage of the year that you're paying $200. Now, something I want to point out is that it will be closer to 200 but not over 200, because the way averages work is it's going to be between the smallest and the largest number there. So let's go ahead and apply this to different isotopes of an element. And so let's say nitrogen has 2 stable isotopes. We have nitrogen 14 and nitrogen 15. And let's say that nitrogen 14 is 99.6% abundant, has a 99.6% abundance, and that oxygen 15 has a 0.4% abundance. Well, is the average going to be closer to 14 or 15? The answer is it'll be closer to 14 because it has a larger abundance. And so if you take a look, nitrogen 14 has a larger percent abundance, so it's going to be closer to 14. And if you look at the periodic table, it happens to be 14.01. So the average atomic mass on the periodic table is 14.01. And if we take a look here, there it is. And I rounded it a little bit, so 14.007. So again, all of these on the periodic table, they are a weighted average, so they are an average. Now, recall that the mass on the periodic table is a weighted average of all occurring isotopes for that element. And the weighted average accounts for abundance, right? So it's pretty much saying the same thing as before. And that is a U. For example, the most common form of carbon is carbon-12, and therefore the weighted average is going to be closer to 12. And so what we're going to do is we're going to talk about how we can actually calculate this weighted average if we're given the different percent abundance. The first thing we want to do is we want to put the given information into a table. And what I will say is I will always provide you a table to put that information in. Then what you want to do is you want to convert the percentage to decimal. And how do you convert a percentage to decimal? Well, you divide by 100. But the other way you can do it is by moving the decimal over twice. So for example, let's say we have 97%. Well, we can convert that 97% to a decimal by moving it over twice. And when we move that over twice, we end up with 0.97. Then what we want to do is we want to multiply the mass times the abundance for each isotope. So it's the mass times the percentage in decimal form for each isotope. And then what we want to do is we want to add together those products. And so what you will see is this is actually really easy. Essentially what you're doing is you're taking the mass, you're multiplying it by the percentage in decimal form, you're doing that for each isotope, and then adding them together. So let's go ahead and do a practice problem. So we have these different isotopes of zinc. In fact, there's 5 of them. There's 5 isotopes of zinc, and we have their percent abundance for each one. Now, before we get started, I want to go ahead and say that we can predict what the percentage should be around. First off, it has to be between the smallest and the largest. So it has to be between 64 and 70 because that's how averages work. The other thing too is it's going to be closer to the most abundant isotope. And look, this one is the most abundant. So we know that it will be close to that. So let's go ahead and do this. So what we want to do is take our percentage, convert it to decimal by moving the decimal place over twice. So we convert to decimal form. Do that for each one here. Now notice here what's happening. Notice how with this one, because we're moving it over twice and there's only one digit to go through, we're going to end up adding a 0 there to where it's going to be 0.0411. This one's over twice as well. And then notice this one also. We go 1, 2, and then we fill it with that 0 there. And so it's going to be 0.0062. So what we want to do is we want to take the percentage in decimal form. We want to multiply it by the mass. So we're going to do that for each one. So go ahead and do that. Once you multiply each percentage in decimal form by the mass, you'll see you'll get those numbers there. And then the last thing you want to do is you just add them together. So let's go ahead and add those together. And when you add them together, you get 65.39. Notice how that number is between 64 and 70, and it is closer to 64 because it's going to because that is the most abundant. Now, I know that technically it's closer to 66, but I want you to see why that is. It's closer to 66 because there's a lot of zincs that have a high mass. So, just a quick tip, you only need to write 2 decimal places. So just write 2 decimal places. And then the other thing I want to point out is, and I think this is going to be really important, this right here is an average. That's the average of all the isotopes. So that's the atomic mass, which is the average, which is on the periodic table. These, however, these are mass numbers. So this is a mass number. This is a mass number. And so those are called mass numbers. And again, mass numbers are protons plus neutrons. And so those are different than the atomic mass. And so the mass number is going to be the mass of an individual atom, while the atomic mass is an average mass. All right, let's go ahead and talk about these practice problems here. So let's say that phosphorus has 3 stable isotopes. We know that it's saying that phosphorus 29 has a 0.16% abundance, phosphorus 30 has a 0.40% abundance, and then phosphorus 31 has a 99.7% abundance. And so should the average atomic mass be closer to 29, 30, or 31? Well, the way you answer this is which of those 3 has the highest or the largest abundance? And you can see that this one is the largest abundance, which is for phosphorus 31. And so the answer for this is going to be phosphorus 31. And if you take a look at the periodic table, phosphorus's average atomic mass is 30.974. And so it says, what is the listed mass? It's 30.974, which is closest to 31. So that makes a lot of sense. So let's go ahead and do this practice problem here. So we have copper 63 is 80%. That's going to be 0.8 when you convert it to decimal. Copper 65 is going to be 0.2. The mass is 65. The mass is 63. All you do is you take the percentage, convert it to the decimal, multiply them. Let's go ahead and do that. And when you do that, after you're done doing that, you just add them together. And there's your average. And it's really very easy once you understand the process. You take the decimal, you multiply by the mass, and you add them together. It's just that simple. All right, let's go ahead and fill in this one. There's a lot going on here. So first off, we have lead 208. This happens to be the mass, so we can just automatically write the masses over here. Then what we can do is we can write the percentages as we go. So we can see that 208 is got a percent abundance of 52.4%. We know that 206 has this percent abundance. Then we know that 207 is this. We know that 204 is this. Then what we do is we convert it to decimal form. And then look at this one, it goes 1, 2, so you are going to have a 0 in there, so it's 0.014. Then what you do is you multiply them. So again, you take the percentage in decimal form, you multiply it by the mass. Let's go ahead and do that real quick. After you're done multiplying them together, you just add them together, and then you get your answer. And it's that simple. All right, so now we're asked, boron has two isotopes, boron 10 and boron 11. What should the masses be close to, or what should the average atomic mass be closer to, 10 or 11? Well, again, which one has the highest percent abundance? Boron 11. So it should be closer to 11. And let's go ahead and take a look at the periodic table. Look at that. It is closer to 11. It's 10.812, which is closer to 11. All right, and that's it. That's for atomic mass units. That's it. And so, again, you take your mass, you multiply by the percentage in decimal form, you add them together. The average should be closest to the most abundant, and it should be between the smallest and the largest. And that is it. That's all you need to know. I hope you guys have a great day, and see you in class.